purpose of this lesson is to learn what the A1 and R1C1 reference styles are, why you may need to use the R1C1 reference style, how to enable R1C1, how to use variables, how to use named references, and how to put comments in your code. If you've ever used Excel, or for that matter, almost any other spreadsheet program that's out there, you're used to using what's called the A1 referencing style. And what this means is that the columns are denoted by a letter, and then the rows are referenced by a number. And so if I want to reference a specific cell, I reference it by the letter and the number combination. And so in this case here, we have B2 would be this cell right here, which is B2. And then this cell is D5, which means it's in column D, row 5. So the A1 reference is what most people are used to seeing. Even though the A1 reference style has been around since the 1970s, Microsoft attempted to change the reference style for Excel in the 1990s to the R1C1 referencing style. What happened was people resisted because they were so used to using the A1 reference style that was used by almost every other spreadsheet program that was out there. So because the A1 reference style was still the default, Microsoft had to adapt to the style used by the other developers. They decided to go ahead and stick with the A1 reference. However, that's only for our benefit. Behind the scenes, Excel still uses the R1C1 reference style. Unlike the A1 reference style, the R1C1 reference style denotes that our rows and our columns are all referenced by numbers. There are no letters to reference them. And the way that it does it is it denotes the letter R and then the row number, and the letter C and the row number. So in this case, this is cell R1C1. The one that's highlighted over here is R5C5. It's in row 5. And it's in column 5. And so if you look here, this is in row 8, column 3. This is one of the reasons why when we start playing with our cells commands and some of the other commands that we use, that they will actually do the rows before they do the columns inside of the parentheses. So the question becomes, why should we learn the R1C1 reference style if everybody else, including Excel, is using the A1 reference style? And the answer is, we've got to remember, behind the scenes, Excel is using the R1C1 reference style. The R1C1 reference style is actually really good for programming, and the reason for it is that our relative positions become easier, and then we can use variables in our cell reference. No longer will I have to know that my cell is in column AB at 234, and therefore it's AB 234. What I can do is I can reference those cells directly by an integer value, which means that I can use variables instead to reference those cells directly. Also, the absolute references are easier. Instead of doing something like $D, $3, it just simply becomes R3C4. The reference will be retained when it's copied. So unlike in the A1 reference style, when we do things like our fill statements where it will automatically go to the next row and go from A to B to C and so forth and change our formula, when we use the R1C1 reference style, they are going to be static references, which means if I copy a formula down, that formula is going to retain the original location. Also, anytime we deal with arrays, any formulas that act upon those arrays are going to require the R1C1 reference style. The way that you enable the R1C1 reference style is actually in the options. So what you do is you go up to the File menu, which remember is called the Backstage View, go to Options, then you go to the Formulas on the left-hand side here, and then on the right you select R1C1 reference style. That's it. As soon as you do that, you will notice that your column names change from letters to numbers. So I have a spreadsheet here, and you notice this is the A1 reference style because I have the letters across the top. And I want to change it, so I'm going to go here to Options, and I'm going to go to Formulas, and then enable R1C1 reference style. And now what you'll notice is that across the top, I no longer have letters. I now have numbers. All right, so the question is, why does this help? What do we need to know this for? All right, so any cell that I'm in will be referenced by its R1C1 reference style. So this is row 5, column 4. So you notice I'm a row 5, column 4, so this is R5C4. One of the things that's really nice with the R1C1 reference style is when you start playing with other cells that are around this. We can reference cells by using an offset by simply specifying how many rows or columns to the left or right or up or down from where we are, and then we can actually specify other cells that way. So if I'm in this cell and I want to reference the one up here, I'm going to just type an equal sign here so that way when I click on this you can see what it does. Now you'll notice that it says R-1, so that's one cell up from where we are right now, but the C doesn't have anything after it because it's in the same column. But if I come over here, now it's row -1, which means go up 1, and then C +1, which means go to the right 1. If I do something like this, then we go row 1, so it goes down 1, and C -1, and then it goes over here. So what we can do with the R1 reference style is we can actually reference cells based on their relative location to where we currently are. So in this case, this is 3 rows down, and down here, this is 8 rows down. If I come way over here, then we're 9 columns to the right. So what happens with this now is I can actually start using variables instead of that 9. I could put a variable there and reference another cell directly without having to worry about A's and B's and things of that nature. And on top of it, I don't have to use the cells command. I can actually reference the cells directly with variables in the formulas without having to reference cells. We've used variables a little bit in some of our prior programs, but we're going to start talking more about them. A variable is nothing more than a named space in memory. But what happens is when we tell the system to create that memory location, we have to tell the system what type of data is going to be stored and how big of a memory location to use. So we have to declare a data type. And every time we create a variable, we have to specify what the data type is. We declare a variable by using the dim command. And then what we do is we specify the data type by typing the word as after our variable name, and then we simply type the type of data. So in this case here, I've dimensioned or allocated memory for a variable called my variable name, and it's being stored as a string. So string is the data type. And by specifying this, the system knows automatically how to allocate the memory to hold the value for this variable. There are a lot of different data types. I'm going to cover some of the basic ones. Integers are going to be our whole numbers, and you'll notice that an integer has a range of -32,000 to +32,000. Now we can convert from one data type to another. So let's say I need to take this value that's an integer right now, and I needed to put it into some other data type, or I have a value that's currently a string that looks like a number. Well, we can actually convert it to a number. So what you'll see here is that we can use the method called cint, and then inside of the parentheses type whatever the value is that we want to convert, and it will automatically convert this value inside to an integer. We also have long, which long is an integer data type that allows for larger numbers. You notice it goes from -2 billion to +2 billion, and we can convert the values, the data type, by typing clng, so C long, and then the value inside, and that will automatically convert whatever the value is to a long data type. Unlike an integer value, a decimal number is going to require 2 memory allocations. One memory location is going to be for the integer portion, and one is going to be for the decimal portion. The computer actually physically can't handle decimal numbers. It can't handle half of a bit. All right, so what we have to do is we have to tell the system that we're going to declare a decimal, and it's going to allocate a space for the for the whole number portion, and a space for the fraction portion of our number. We have what's called a single, which ranges from 1.4 e to the -45, which if you remember back to elementary school, it means we're going to take this decimal place and move it to the left 45 places. And then we can go all the way up to 3.4 to the 38th, which means that we're going to move this decimal place over that many places. So we're talking a large range of numbers. But there is a possibility that this number is not big enough. If we want to convert something to a single, we use the CSNG, type the value in, and that will convert it to a single. If we need a number that has a much smaller or much larger number, we can use a double. A double does use more memory, but it has a much larger range of values. To convert something to a double, we use CDBL, type the value inside, and it will convert it to a double. So if we have something like an integer and we want to start playing with adding a double to it. So if I have the number 3 as an integer and I try to add 1.2 to it, what will happen is the system will actually ignore the decimal portion of that number and we'll end up with 4, even though I told it I wanted to add 3 plus 1.2. So for me to be able to add decimal numbers together, both of our numbers are going to have to be decimal format, or the system has some types of data that it can actually automatically convert for us. We have text strings, which are going to be characters of text. These are usually from the Unicode or the ASCII data sets. We use the CSTR value method to convert to a string. Be aware that a string has to be enclosed in double quotes. We also have currency, which this is going to be characters that deal with monetary value. Be aware that the system will automatically format these values to match the currency formatting configured in regional settings. Do not put a $sign in one of your currency values. Otherwise, the system will actually throw an error. You just simply type the numbers, no commas, no $signs, no other characters, just the number, and the system will automatically format it for you. We can use the CUR and then the value to convert it to currency. There are some exceptions, some little caveats with date and time. When we're dealing with the date and time, these are not text strings, they're not numbers or anything like that. What we need to do is we need to surround these with number signs. And the reason for this is we see it as year, month, and date, or in this case is month, day, and year. And then we see the time as 6:52 p.m., but it's not really that way in the system. The time is going to be in terms of milliseconds, and so is our date. Our date is actually in terms of milliseconds from what's called the epoch, which is going to be back in the 1970s. We do also have another type of data, which is called a variant. Now this is going to be if I don't declare something as a data type, it'll automatically make it a variant, or I can specifically state that I'm dimensioning a variable as a variant. And what this is going to be for when we have a variable that we don't know what the data type is going to be later on in our program, then we can use a variant, and what will happen is the first time that that variable gets used, the system will automatically determine the data type based on the value that we're putting into it. This is very useful, especially when we're going to do a loop or something like that on a large amount of data, and we don't necessarily know what kind of data the user typed into that particular field. We can just simply allow it to be a variant, and then as soon as we pull in some value from the spreadsheet, then we can let the system automatically determine what data type it wants to be. Variables have what is called scope, and this is going to be their lifetime. Variables can either be local or global variables, and the type of variable depends on where you actually declare it. Local variables are going to be the ones that we declare within a subroutine. Global variables, though, are going to be declared before any of the subroutines. So we actually go to the top of our program, type in our global variables up there. Now, the scope, like I said, that determines the lifespan of the variable. Local variables only exist for the duration of a subroutine. Now, what that means is that I can have a variable called I in every single subroutine that I have. And the reason that I can do that is because if I declare it as a local variable, then even though they're the same letter for what we see, as far as the system is concerned, every one of those is completely separate and they can all be isolated from each other. Now, a global variable, though, a global variable exists for all of the subroutines. So if I declare the variable I at the global level, I cannot dimension I again inside of any of the other subroutines. But what happens is if I declare something as a global variable, then that variable is going to exist for the entire life of that Excel workbook. And the life of the Excel workbook is going to be until you actually close the workbook. When we declare global variables, we're not going to use the word or the command dim. Instead, what we're going to use is either the statement called private or public. Now, what this means is that I'm declaring the access level. What can other subroutines and other programs see of my variables? All right, so a private variable is the one that we're going to use almost all the time unless you have some specific need for public. But a private variable is only accessible to other subroutines contained within the same VBA project file, the module. So if I only have one module for my program and all of the variables and all of my subroutines are within that same module, I'm just going to leave it as private because I don't want other programs to be able to interact with my variables. However, if I do have separate modules, or even if I have another workbook that needs to access variables within another workbook, which, by the way, you really don't want to do if you can help it, then we're going to make it public, which means that the other subroutines, the other methods, the other modules can all see my variable and they can all manipulate it. As we write our programs, we need to make sure that we include comments in our code. And comments are just simply things that are there for our benefit as the developer. These are going to be text that we type in that is not interpreted during the runtime. What this is going to be things like, I'm creating this variable because of whatever, and you actually type that into your code, so that way the next time you go back in there and you try to remember why that specific line of code was there, you can look at your comment and go, oh, that's why it's there. This makes troubleshooting a lot easier, and it's necessary for when we modify our code, especially if it's been months or years since the last time we looked at it. Because chances are, by the time you go back and look at this code again and try to figure out how you did it the last time, you've forgotten by now. But if you have comments in there, then you explain why you did it a certain way, and then you can remember. Comments are denoted by a single apostrophe or single quote at the beginning of the line of code. They will turn green, which means those are comments, and like I said, the system will flat out ignore them. And when you step into the program and watch it run, you actually watch it just flat out skip right over top of those comments. It will not process them at all. All right, so I have a blank workbook open and I have my VBE open. And what I want to do is I want to start playing with some variables. All right, so what I'm going to do is I'm going to make a new subroutine and we'll call it playing with variables. All right, so this is my section of code where I want to play with the variables. Okay, so what I'm going to do is I'm going to dimension a new variable called my salary. All right, now if I were to just simply press enter, it did declare the variable called my salary, but it doesn't have a data type. What that means is this is a variant. But if I wanted to actually specify what this is going to be, then what I'm going to do is I'm going to specify that it's currency. And then I'm going to dimension my name as a string. And then I can do something like dimension my favorite number as a integer. And then I can do something like dimension, let's say pi, we'll just call it pi, as, and then this is going to be a double because this is an irrational number, has a very long decimal place. So we want to use as big of a memory location as we can for something like pi or any other irrational number. All right, so what happens is when I dimension these, the system actually will allocate memory for these variables. And then what it does is it knows what data type is going to go into them. So it knows how the memory is actually allocated and it knows how to put values into it. All right, so what I can do is I can say something like my salary is equal to 30,000. And then my name is equal to, now this is going to be a string, so therefore I need to type it in quotes. And then my favorite number, and we're going to set that equal to 3. And then we can set pi equal to 3.14. And yes, there's a lot more to it, but we're going to leave it just like it is. All right, so what happens now is the system will take this number, 30,000, and it will stick it into my salary. And this is allowed because it's currency. And then it will take my name, which is a string, put it into my name, and that's allowed because it's a string. And this number 3 is going to go into my fave number as an integer, which is allowed here. And then pi gets the value of 3.14, as a double, and that's allowed because a double is a decimal data type. So what I'm doing is I'm just simply specifying that I've allocated these memory locations, I've specified the type of data that is supposed to go into those, and then down here in this little section, I actually declare the values that should go into those. All right, so I want to provide a comment. So the way that I do that is I'm going to put an apostrophe here, and then usually we'll do something like declaring variables. All right, so now what that did is that just simply made a comment, and this particular comment will get ignored. All right, so then what we're doing down here is we are entering values into variable locations. All right, so now what I have is some comments that I can come back to. So 2 years from now, if I'm trying to figure out where that 30,000 came from, oh, hey, I was putting values into those variables. Now I want to write those values out to the spreadsheet. So we're going to write values to, it's the C1 column, because we're in R1 C1 format right now. All right, so what I want to do is I could do cells and then specify 1, 1, and then dot value is equal to something. Okay, or the other option is that I can actually use the R1 C1 formatting style. All right, so what I'm going to do is I'm going to open my square brackets. I'm going to do R1 C1, just like we did before with the A1 style. Dot value is equal to my salary. All right, we're going to do the same thing with the other one. So now it's R2 C1, because we're in the same column. Dot value is equal to my name. Then we'll do R3 C1 dot value is equal to my fave number. And then we're going to do R4 C1 dot value is equal to pi. All right, so now what we're doing is we're taking these values that are here and just simply writing them out to our spreadsheet. All right, so I'm going to step into this. And so you'll notice the yellow is what's going to run next, so it hasn't done anything yet. All right, so let's go down here. It did declare our variables for us, and what it did is it declared those, and you'll notice that they all will have an initial value now. So the initial value for currency is going to be 0. The initial value for a string is going to be a double set of quotes, so that's no value in there. The integer is 0, and then the double is 0. So now, once I run this, the next step here is going to put 30,000 into my salary. So now, if I come up here and look at my salary is now equal to 30,000. Okay, the other ones have not been populated yet, so let's go ahead and do those. All right, so now, these all have values to them. This is a text string. Come on. That's a text string, so it has my name in it now. And then we're going to write these out to the screen. All right, so if I run this, now one of the things you'll notice here is that it ended up with a whole bunch of pound signs, and the reason for that is just simply that the column's not wide enough. So we'll make the column wider in just a minute. Okay, so we're going to put my name, my fave number, and pi, write those all out to the spreadsheet, and there we go. So we have all of our values from the variables that I dimensioned. We declared all the variables. We declared a data type, we put data into them, and then we use the R1 C1 style to write those back to the spreadsheet. All right, so the question is, why is this currency important? Well, watch this. If I were to take this off of here and just do this, dimension my salary, and if I were to go through and write this out, watch what happens when I run this. Actually, it's not going to overwrite it, so let's go ahead and get rid of this. All right. We're going to go run it now. Now, the thing is the system knows that that's currency. Unfortunately, it remembers it from the last time. So I'm going to flat out delete this whole row just so that it doesn't remember the formatting, because our basic formatting is general. Okay, so when I run this time, there we go. So now we have 30,000. Now, the reason it did 30,000 is it declared my salary, but it declared it as a variant. And a variant just simply means that it doesn't know what the data type is, so therefore it's going to assume the form of whatever data goes into it first. So since I put an integer value into it, my salary is now an integer value. So we want to make sure that we declare it as the correct data type, so that way it will set our formatting correctly when we write it back to the spreadsheet. All right, so let's go ahead and put this back as currency. And then I want to try to put something into this like let's do that my salary is 30,000 like this. All right, so I'm going to go delete this column again. And we'll forget all of our formatting. And I want to try to run this. All right, so let's step into it. Oh, hey, we got an error. All right, the reason we got an error is we tried to put a $, which is not a valid character, into this. Oh, okay, so let's get rid of the $. Let's try it again. Oh, same thing. All right, so the problem is that when we deal with these, if we're trying to put string characters in, we can't put a string character into a number data type. So be aware when we deal with numbers that our numbers have to have no special characters in them, just the numbers. All right, so let's try this one down here. Let's say my favorite number really is pi, so let's make it 3.14. Oops, it's still running. So 3.14, and let's try to step into this. Okay, so it's going to let me do it. Let's go through the program, go down here, we declare my favorite number is 3.14. All right, so if you watch, my favorite number is 3. And the reason for it is because I declared it as an integer, the system will automatically truncate, meaning get rid of all of the decimal portion of that number. It has nowhere to put it. Because I declared it as an integer, it only has the memory location for the whole number portion of my decimal value. It does not have a memory location for the fraction part. So we need to make sure that when we try to put values into these, that we really do have values that match. And in this case, it's going to go ahead and just dump the last of that off. I mentioned using a named reference in a prior lesson. And what I did was I just simply took an area like this, and I came up here and I gave it a name. So this is going to be my range. Okay, and what I want to do is I want to put some numbers into this range. This goes from 7 through 13. So let's do 6. Actually, let's go ahead and make that a number instead of 0. Okay, and what I want to do is I want to have the sum of these values up here. Now I could do something like highlighting these, and then I could do auto sum, and that'll work. But what happens though is that I've called this my range, so I actually can play with it as the name itself. And so what I'm going to do is I'm going to say that this cell down here is equal to the sum of my range. Okay, so you'll notice here I have my range. I'm going to type it out. And it automatically highlights it. So notice that is my range. Now, if I were to do something like use the sum up here, that will work. And it'll do something like do the sum of R6, C7 to R13, C7. But what happens is, what if I were to put a new value above it or a new value below it? Well, I would have to redeclare my range for my sum. And when I play with named ranges like this, I don't have to do that. All right, so what I want to do is I want to add some numbers up here. And I want to get them to add together. Now, they didn't do it because these are not part of my range. All right, so I want to manipulate my range. I want to change what my range is. So for me to do that, I have to go back up here to the Formulas tab, go to Name Manager, and then there's an icon down here at the bottom that will allow me to specify what my range is. All right, so I'm going to go ahead and click this, and you'll see that my range right now goes from the 6 down through the 5, but I want all of these. So what I'm going to do is I'm going to re-highlight these, press Enter, and then now it will save my range. So do you want to save it? Yes. And you'll notice my value here actually changed and updated based on the values that are in that new range. I didn't have to change anything in my formula down here. I just simply redeclared what my range is. Now this becomes helpful for if I have 30 different formulas that are all based off of that range, and I decide to add something to it, I can either go and update all 30 of my formulas, or I can update my one range. And if I update the one range, it's a lot easier and less chance of me actually making mistakes in what the range is or forgetting one of the formulas that I have to modify. In this lesson, you learned what the A1 and R1C1 reference styles are. You learned why you need to know the R1C1 reference style. You learned how to enable it, which was through the File Options menu under Formulas. You learned how to use variables and the different data types that we have and what happens if we don't use the correct data type. You learned how to use names for the named ranges. And then you also learned how to put comments in your code.